Assalamu alaikum. Our agenda for today is to continue our practice with the reading comprehensions. The worksheet for which is given below, so you can print that out and start practicing. The second thing we'll be looking into is to start off geometry, which is the main goal for today. We want to start off geometry and revise a few concepts that we most probably know already, based on lines, angles, and triangles. So let's get going. Just to review a few things. First of all, let's say we've got a line and they're saying, what's the angle of a straight line? You've heard that before? What's the angle of a straight line? So the angle of a straight line is 180 degrees. Do we know that? So the angle of a straight line is 180 degrees. You could split it into 2, into 3, into 4, into how many ever. All of them would add up to give me 180 degrees. That's something we can review. The second thing we need to review is how about the angles around a point? Angles around a point, let's say I'm starting here, and I go all around. How many degrees is that? That's a total of 360 degrees. 360 degrees. So angle on a straight line is 180. Angle around a point is 360 degrees. How about the angles of a triangle? So we know that the triangle has 3 angles. They all add up to give me how much? Do we know? Let's say the values are x, y, and z. So x plus y plus z, all 3 of them would add up to give me 180 degrees, correct. That's done with the angles. How about the area of a triangle? Do we know what the area of a triangle is? Let's review. The area of a triangle was half times the base, which is this one over here. The base times the perpendicular height. So we're not talking about the slanted height, no, we're talking about the perpendicular, this one, the perpendicular height. So half times base times height is the area of a triangle. So now that we've reviewed that, let's take a look at one last thing I'd like you to review before we go on to the practice questions. Let's say I've got a set of parallel lines. So these two lines are parallel to each other. And then I've got a transversal cutting through them. I've got this transversal cutting through them. So we've got a total of 8 angles that are formed. 1, 2, 3, 4, 5, 6, 7, 8. We're looking into, so first of all, we need to categorize them as corresponding angles, interior angles, alternate interior angles, and alternate exterior angles. 4 types of angles that are formed. The corresponding angle would then be, for example, 1 over here. So it's on top of the line, on top of the parallel line, and to the right, to the left of the transversal. It's on top of the parallel line, to the left of the transversal. So I do the exact same angle at the second parallel line, on top of the parallel line, to the left of the transversal. So angle 1 and 2. Angle 1 and 5, my bad, 1 and 5, angle 1 and angle 5 together are the corresponding angles. Likewise, you can pick up anything else. Let's say if I pick a 4 here, then I pick an 8 here. So 4 and 8, or 3 and 7, so forth. So those are the corresponding angles. And what we need to know about the corresponding angles is that they are equal. Corresponding angles are equal. So whatever the value of angle 1 is, angle 5 would be the exact same thing. Corresponding angles are equal. Interior angles, let's say interior angles is, for example, first of all, they're supposed to be inside the parallel line. So if I'm talking about 4, that's on the right of the transversal, then 6, which is also on the right of the transversal. Or if I'm talking about 3, then it has to be 5 with it. So 3 and 5, or 4 and 6 form the interior angle. Let's write over here angle 4 and angle 6, for example, or angle 3 and angle 5, for example. What we need to know about interior angles is that they add up to 180 degrees. 180 degrees. So corresponding angles were equal and interior angles add up to 180 degrees. Next, alternate interior angle. Now we already know what interior angles are. Alternate, can we make a rough idea of what alternate angles would be hinting towards? So let's say if I took an interior angle at 3, I take the alternate interior angle. So not 3 now, I take the 6. Not 5, I take the 6. So they're both inside and inside, but on the opposite sides. Do you see? So which is why we refer to them as alternate interior. So we are looking at either angle 3 and 6. Let's say angle 3 and angle 6, or you can also say angle 4 and 5. Now again, alternate interior angles again equal each other. Alternate interior angles equal each other. Then fourth thing that we need to know, alternate exterior. Alternate again, if one of them is on the right, the other one's got to be at the left. But this time they are both on the outside. Nothing's on the inside of the parallel lines. This is the inside of the parallel lines, not here. They're supposed to be on the outsides of the parallel lines. So let's say if I go with the angle 7, then on the same side I've got the 1, but I don't need the same side, I need the opposite side because it says alternate exterior. So I'm talking about angle 7 and angle 2. I hope we reviewed that quite well. I mean, I'm sure you know that already if you've studied geometry, but just as a review. So again, alternate exterior angles are also equal to each other. With that done, for example, let's see, something like this. Would we be able to solve this? Let's say, for example, we want the value of x. We want the value of x. Can we work it out? First of all, I need to identify. I've got my transversal over here. These two are parallel lines. This is one of the angles, which is on the outside, so it looks like the exterior, because I've got one on the left and the other one on the right. So it looks like I'm looking at alternate exterior angles. Alternate exterior angles, as we know, are equal to each other, so I would equate them like this. Bring the x's to the same side and regular numbers to the same side. So that's 5x, take away 3x. That's a 32, and that's a 2x, so x would be a 16. Just for a rough idea, like something like this comes up with parallel lines, transversals, we know what the relationship between the angles is. Let's get started with a few practice questions then. So let's go. I encourage you to try and do the questions yourself, so you pause the video and give it a go, so that if you get it right, perfect, you can just fast forward on to the next question. If you do somehow find yourself struggling through it, you can come back to the workout and try and pinpoint exactly what you were getting stuck at. So it gives a good idea of where we are in the concept. So pause it, try it yourself, and then you come back to view the video. Let's go. A straight line is divided into 5 equal angles. Now when someone says straight line, students have done something like this. 1, 2, 3, 4, 5. 5 equal parts, that would be right. They are specifying angles, which means I know they're talking about the straight angle, which looks like this. It's a straight angle. I know that the entire thing is 180, but it's split into 1, 2, 3, 4, 5. So that's a straight away 180 divided by 5. How much would that be? I have not a clue. So what I would do is split it into something that I do know. For example, 180 separately. So I know 100 divided by 5 is a 20, and an 80 divided by 5 is 40 by 5, 8, 16. Answer 36. So that's my answer. Number C, part C, is the final answer. Let's take a look at the next question. How many slices does a cake have if the internal angle is each slice is 45 degrees? So we've got a cake, and it's split into pieces, and each internal angle is 45. Do we know what the total is, what the total of the whole thing is? Angle around a point. Yes, that's 360, and it's split into 45-degree angles. So what's the total of that? That's the question. So 360 divided by 45, I know that they come in the table of 99, yes, that's 9 times 5, and that's 9 times, 36 is 9 times 4, but then because there's a 0 with it, here, we look like this. So 9 and 9, they go off, 5 times 1, 5 times 2, I'm left with a 4 times 2, that's an 8. So we've got 8 slices, each in total angle 45 degrees. Next question. What is the perimeter of the triangle? Perimeter of anything at all is you add up everything, the outline. You end up adding the outline. We've got the outline over here. We know that this side is 8x plus 3. 8x plus 3. Plus, we know this side is 3x plus 7. 3x plus 7. Plus, we know this side is 5x plus 7. Okay, let's put them together. The x's together, 8, 3, and 5. That's 16x. Then I've got 3, 7, and 7. Oh, my bad. Let's take a look at this. This is supposed to be a minus. Good that we caught the mistake. Okay, so that's 14. 7 and 7, 14. Minus 3, that will give me an 11. So plus 11. But that's not in the options. I've got an x over here. I need to do something about it to be able to move on, add, and get the perimeter. How do I get the value of x? Question. Now, I do realize that there's some extra information given to me. 80 and 50. For what? They've got to, sometimes they do give you extra information to confuse you. But in this particular question, I can actually make use of it because I know this is 80, this is 50. Can I work out the leftover angle? Can I work out this angle? I know that the entire thing is 180. I take an 80 out of it and I'm left with 100. And then this 50 goes away as well. So I'm left with another 50. Once I know that this is 50, the angle is 50, I know that it's an isosceles triangle because this side should be equal to this side. Why should they be equal to each other? Because this angle is equal to this angle over here, right? So now that I know that, I can say that 8x minus 3 should be equal to 3x plus 7. They're both equal to each other. And that way, I've got an equation and I can just solve it, bring the x's to the same side. 3x, that's 5x. Take the 3 to the other side, that's a 10, equals 10. 5x equals 10, so x has got to be 10 divided by 5, 2. Now that I know x equals to 2, I can use it, put it back in here to get the perimeter. So that's 16 times 2 plus 11. That's a 32 plus 11, which is a 43 answer. Alright, let's move on to the next question. By the way, my workouts, because I try to explain it in as much detail as possible, making sure everyone understands, it's very step by step, which is why it looks like it's huge, and that would take us maybe like 3 or 4 minutes to work in the test, but actually, if you know how to go by it, like if you try and do it one more time, it actually only takes about 20 seconds. So it looks elaborated, but it's actually not so huge, the answer itself. Let's take a look at the next question, question number 4. I've got 2 triangles stuck together, so there's one triangle here and the other one over here, right? How do I get the value of x? They're saying, what is the value of x? Whatever this angle is, this would be equal to it. They're both equal to each other because something like this is called vertically opposite angles, and vertically opposite angles are equal to each other, right? Which means that this one plus this one over here, the sum of these two would be 180 minus, let's say this angle is A. So it's 180 minus A. These two, the sum of these two over here, because the whole thing is 180. So I want to take away the A from it, so I'm left with 3x plus x, right? The same thing happens to these two, because 180, the whole entire triangle, take away the A would leave me with these two, the sum of these two. So 180 minus A should be equal to 2x plus 4x minus 44. Now that I know that equal to each other, I can just go ahead and equate them. Because I know that this part is equal to this part is equal to this part. So I can just go ahead, because this is not necessary for me. I can just go ahead, equate the other two. Okay, here. And now I formed an equation. It's very easy for me to get all the x's onto the same side. 3x plus x, that's a 4x. Minus get the 2x from the other side. Actually, there is no. I will take things to the other side, actually. I will take the negative 44 to the other side, make it positive. And 2x plus 4x is a 6x. And I've got a 4x over here that I plan to take onto the other side. Now, 6x minus 4x is 2x. 44. Divide both sides by 2. 44 divided by 2 would give me a 22. So the value of x is 22. Oh, right. Let's move on to the next question. Okay, question number 5. What's the value of x? So they want the value of this angle over here. Now, let's see what we can do. I can see that these are 2 parallel lines, and I can extend this transversal, because when I extend this transversal, I know that this angle is interior to this angle. Yeah, they're both interior, they both have to be exactly the same. Why? Because they are alternate interior angles. So this angle is a 35. If I know that's 35 and I know that's 45, can I get that angle over here? I can get that angle, right? Let's see. So 35 and 45 gives me an 80. So that angle is an 80 degrees. If that angle is an 80 degrees, can I get the left over? Because you see that it's a straight line. That's 80. So that, which is marked x, will be 100. Actually, let me do it in an easier way. I thought of telling you this later on, but I think I will tell you first the rule to it, and then I'll explain you to it. So we know that's a 35. We know that's a 45. We need to get this, right? From now on, anytime you see a shape like this, and when two of these lines are parallel, this is given, and this one's given over here, and they ask you about this angle here, always remember that these two add up to give you the middle angle. So for example, in our case, 35 plus 45, which is an 80, is your answer here, okay? Let's say another question comes up, they go like, okay, this is 50, these are parallel lines, that's a 40, what's this angle? Straight away, we're going to go 50 plus 40 is a 90, which is this angle over here, okay? Now let's take a look at the explanation part of it. So 35, so that would also be 35, yeah? Now I want to get this angle over here. So do you see the triangle? This one. This is the triangle, so 35 plus 45 plus, let's mark it with this one here, let's mark it with a question mark, is 180, right? Work that out, so you would get a question mark equals 180, take those two to the other side, so that's 80, you're left with 100. So this thing is 100. if you know this is 100, and actually I know this is 100, I'm interested in the rest of it. Do you see that it's on a straight line? So 100 and how much gives you 180? 80. 100 plus 80 gives you 180, so x equals to 80. That's the theory part of it, but from now on, because we know that this and this adds up to give you this angle over here, we can just go forward with it straight away without going through this entire hassle of the workout, okay? Next question number 6. What's the ratio of the shaded region to the area of the big triangle? When questions like these come up where you've been given no values at all, nothing, they want you to try and use sort of your common sense. The idea is to split the entire figure. Into equal portioned shapes. So for example, in this one, we've got, let's say, one triangle, triangle 1, right? You see triangle 1, triangle 2, triangle 2, triangle 3, and the one in the middle, triangle 4, the shaded part. So do you see that we've got a total of 4 triangles, and how many is shaded? 1 of them is shaded. So 1 out of 4 triangles is shaded. So 1 to 4 is the ratio of the shaded part to the whole. Makes sense? It's as straightforward as that. Until they bring in numbers, like in question number 7. They've got in a few numbers. They're saying that the area of the triangle is 128. The area of the triangle, actually, this is the triangle ABC, and the area of it is 128. Let's see how we can work out the area of the shaded region. The first thing that I want to do is split it into equal portions. So I've got triangle 1, triangle 2, triangle 3, triangle 4. 4 triangles, right? So that's 128 split into 4 triangles. That gives me a 32. Once that's done, now I know that the area of the middle portion, the one that looks like this, the middle portion is 32. Let's move on from there. So I'm working at the middle portion. Let's take a look. How many triangles do I have? 1, 2, 3, 4. The one in the middle. 4 triangles again. So that's 32 divided into 4 triangles again, which means each triangle is an 8. Each triangle is an 8. So now I'm at this triangle over here. This whole thing is an 8. Done. Now I want to split it further into smaller triangles. Then I've got one triangle here, triangle 2, triangle 3, and the one in the middle. This one, the one that's the shaded part. So 4 triangles. Again, I would take 8, split it into 4. That's 2. So the shaded portion, the one in the middle, is 2. I hope that makes sense. You can always review, go back and listen to it one more time. It's not difficult, but because we haven't done questions like these at school, it might come across a bit structured. It has a few steps to it. So that's that. Let's move on to question number 8. Question number 8, they're saying, what is the value of x? Now, one more thing we need to know about triangles is this, that any two internal triangles, let's say that this is A and this is B, add up to give us the remote. Remote means it's not touching A and it's not touching B, it's over here at the third angle, the remote exterior angle. So any two angles of a triangle, let's say if this one's over here, any two angles of a triangle add up to give the remote exterior angle. That's something we need to know. Actually, we're just reviewing. I'm sure if you've done geometry before, you've heard of that already. So, for example, what's the value of x? What's the value of x? We would just go like, okay. So, according to what we just learned, x plus 50, the two interior angles, should add up to give us the remote exterior angle, which is 120. So there, x equals a 70. Take 50 to the other side. 120 take away 50 is a 70, so that's that over there. I know that we could have also done, like, we know that the whole entire thing is 180, right? 180 take away 120 would give us a 60, and then 60 x and 50 would give us 180. That would also give me the answer. But it's important to know this concept because it comes up in not just simple questions. Sometimes it might come up in a bit more complicated scenario. Let's take a look at question number 9. Very similar concept to the one before. Which of the following is correct? They're not interested in values this particular time. They're only interested in equations. They're asking which equation is correct. So I've got to try and fiddle around with this triangle. I know that because they are vertically opposite angles, that's a y, right? They're vertically opposite angles, so that's a y. So my new diagram looks like this. I know that's a 90 and that's a y, right? Again, the sum of two interior angles add up to give us the remote exterior angle, right? Is that in the options? Not really, because x equals to something is only over here. X equals to 2x, which is 2y, which is not even correct. Everything else is in terms of y. Y equals to something, right? So let's make y the formula. I'll take 90 to the other side. So the x take away 90. Do we have that in the options? Yes, we do. Here. Part B. Y equals x minus 90. Done. Let's move on to question number 10. What is the sum of the angles wx, y, and z? When they come up with questions like these, naturally, your human mind is tricked into thinking, okay, let me find out the value of w, let me get the value of x, of y, of z, and then I would add them all up together. That's how everyone tends to think. But what I would like to highlight is sometimes when they're asking you questions like these, actually a lot of times when they're asking you questions like these, they don't expect you to work them out each value individually. Actually, as a matter of fact, you can never work them out individually because we don't have enough information to work out what each of them would be. So basically the question is the sum of w, x, y, and z would equate to give us what? Now I want you to pay attention. Take a look at this triangle over here. Take a look at this triangle, right? 60, w, and x. They all add up to give me 180, right? So what would this give me? W and x only. I want to take away 60 from it so that I know that the sum of them two add up to give me 120. The sum of these two adds up to give me 120. Right? You can assume that this is 60 and this is 60. Clearly, they don't look like they're equal to each other. W and x, they don't look like they're equal to each other, but no problem even if you sort of assume it wouldn't make a difference in this particular question. Then I want you to take a look at the big triangle, the angles of which are 60, x, y, and z. So 60, y, and z also add up to give me 180. Y and z add up to give me how much? The total of them is exactly the same as what we got over here, 120. So I know that these two add up to give me 120. So 120 and 120 is 240. Answer. Again, like I said, it looks too elaborated, but actually just, quite simple. You take a look at the first triangle, you go like, okay, this is 120. You take a look at the big triangle, you go like, okay, that's 120. Add them up, 240, that's the answer. Next, before we move on to any other questions, I just want to highlight a few areas, some extra information that I'm sure you know of already, but we're just revising. Okay, so now there's something called special triangles in geometry. Special triangles come up in two ways. Sometimes they are special because of their angles. Sometimes they are special because of their sides. let's take a look at the sides first. That's easier. So if I take a look at this one here, I know that this side is 3, it's a given, and that side is 4, it's a given, and that side is 5, is a given. So basically 3, 4, 5, this triangle 3, 4, 5 is a special triangle. So the minute, for example, you don't see 3, 4, 5, but let's say you end up seeing like there's a 30, 40, and something triangle. Instead of working that out, you can straight away go like, okay, it looks like a special triangle because the sides are products of 3, 4, and 5. 3 times 10, 4 times 10, 5 times 10, 50. So this side is 50. So this is a special triangle, which you don't need to work out. You can just straight away get the answer. For example, maybe everything doesn't multiply by 10. Maybe it multiplies with, let's say, 2. So 3 times 2, 6. 4 times 2, 8. 5 times 2, 10. So then 6, 8, 10 would also be a special triangle. Why? Because 3, 4, 5 is a special triangle, and all you did is just multiplied it by 2 to get the 6, 8, 10 triangle. So this is 3, 4, 5 is a special triangle because of its sides. Otherwise, how would you calculate something? Let's say this is given 3, this is given 4. How do I work out this side? Do we know the Pythagoras theorem, by the way? Reviewing again. So the Pythagoras theorem states that what you do is you do the hypotenuse, you square it. Take the hypotenuse is the side length opposite the 90-degree angle. So hypotenuse squared is equal to any of the sides, it doesn't matter. Side 1 squared, let's say, plus the side 2 squared. So side 1 squared, which was 3 in our case, and side 2, which is 4. It doesn't matter even if you switch them around, as long as the hypotenuse is on one side and the other two legs are on the other side. So hypotenuse squared equals, in our case, this is 3 squared, 4 squared, that's 3 squares are 9, 4 squares are 16, that's a 25. So basically hypotenuse squared is 25. Square root both, so we get the hypotenuse as 5. The hypotenuse is 5. It took us a bit of workout, right? It took us a bit of workout, which is why we'd like to remember that 3, 4, 5 is a special triangle, so that we don't have to do this minute workout when a triangle with those side ratios comes up. Then let's take a look at the second type of special triangle, which is to do with the angles. So now the triangle is special because of its angles. 30, 60, 90 are the 3 angles. If a triangle has the angles 30, 60, 90, we consider it to be a special triangle. For example, in this case, it's a 30 here. 30, 60, 90. Do you see? It's a 30, 60, 90 triangle. What we need to remember about this is the 30, the 60, the 90 triangle. What we need to remember is the length opposite 30 is an x, for example, whatever the value is. Let's say an x. The length opposite 60, is x root 3, and the length opposite 90, this one here, is double of what's opposite 30, 2x. So that's the angle ratio you want to remember. That's the angle ratio you want to remember when it comes to the 30, 60, 90 triangle. 30, 60, 90 triangle, the length opposite 30 is x, the length opposite 60 is x root 3, the length opposite 90 is 2x. It's basically, do you see that the length opposite 30 is half of the length opposite the hypotenuse? That's one thing. You want to jot it down, by the way. If you don't know this already, you want to jot the information down so that you can refer to it when you need it. The next type of special triangle is the 45, 45, 90 triangle. The 45, 45, 90 triangle, take a look. The length opposite 45 is x, the length opposite this 45 is also x. Okay, let's mark that. So this is an x. We put, and the length opposite 90, is x root 2. The length opposite 90 is x root 2. So that's also something we'd like to remember. So basically, this is the 2 takeaways, 1 and 2. Ratios, we're going to need them in the upcoming questions, right? Let's go. Let's take a look at a few questions that are using these concepts. Question number 11. They're saying, what is the height of the tree? What's the height of the tree? Which means this thing over here. Do you see the triangle? Do you see this triangle over here? It's a 90 degree, a 45 degree. What's the angle over here? We've studied this already, right? 45, 45, 90 is a special triangle. So the length opposite 45 is 100. Remember the ratio? X root 2. The length opposite x is, so that's like the 45, 45, 90. So the length opposite 45 will be the exact same thing as this length over here, opposite 45, which is 100. Straightforward answer. Obviously, if you have your calculators, you can apply trigonometry, which is not the case when you're sitting for your GAT test, so which is why we need to know these things. Second, what's the value of the angle x? So this is missing over here. Now, how do we get this angle again? I know that this is a circle. This is the center of the circle. This is the radius, and this is the radius. Both the radii are supposed to be equal to each other. If both the sides are equal to each other, the angles also have to be equal to each other, which is why if this is a 45, this also has to be a 45. Reason being, this is a radius and this is a radius, which is why they are equal to each other, so the angles also have to be equal to each other. So the value of the angle x is 45 degrees. Let's take a look at the next question. The next question is using what? What is it using? Do you see this shape over here? It's using some sort of a special triangle. Spot it. I've got a 30 here. I've got a 90, which makes this a 60. So we've got a 30, 60, 90 triangles. Who remembers the ratio of the 30, 60, 90 triangle? What was it? We had an x here. And we had x root 3 here, and we had a 2x over here. Now, why do we need this? First of all, they're saying calculate the shaded area. So this part is shaded. Do we see that it's a triangle? The shaded thing is a triangle, right? I have no values over here. The only thing I can tell is that this is a square, reason being all the sides are tick marked. This means that all the sides are equal to each other, which means it's a square. So basically, if I get this side over here, I'll be able to work at the square, right? So let's see, how can I work about it? I know that the length opposite 90 is 8. Do you see? The length opposite 90 is 8. Can I then work out the length opposite 30? The length opposite 90 is 8. The length opposite 30 should be what? Take a look at this. We know this is x and that's 2x. So basically, when you're coming from 2x to x, you halve it. So 8 would halve to give us 4. So this length over here is a 4. Which means all the sides of the square are 4, 4, 4, 4, right? Now, coming back to working out the shaded area, I can do it as whatever way I like. I can get the area of the square. What's the area of the square? Although we'll be doing this in detail in the next lesson. What's the area of the square? Area of the square is side times side, which is 4 times 4, which is a 16. But then do you see that it's split into 4 parts? So I would say 16 divided by 4, which gives me a 4. That's the answer. I could also alternately do what? I can work out the area of the triangle, which is half times base. That's the blue line is the base. Half times base, which is 4, times the height. So that's the height. I know that the whole entire thing is 4, so half of that would be 2. Work that out. That would also give you a 4. So you can work out the area of the triangle, area of the square, however, whatever you do, the answer is going to be a 4. Next question. They're saying calculate the shaded area. The shaded area of this triangle is basically everything. Take away this small square. How do I know if it's a square? The tick marks. The tick marks over here are telling me that it's a square. So the entire triangle, take away the small square. So let me work it out. The entire triangle, area of the triangle is half times base times height. Then I want to subtract from it the small square. Do I know it's square, which is supposed to be side times side, side times side? Do I know the sides? It's a 2 and a 2 because they're all equal. So let's say 2 times 2, that's a 4, right? How about the triangle? I know that the base of the triangle is an 8, so let me fold that in. How about the height? Do I know the height? Do I know this already? I can use the Pythagoras theorem. I can use the Pythagoras theorem. Hypotenuse squared equals 8 squared plus something squared, and that's my answer. Or, to make things easier, the minute I spot, I can see this is 4 times 2, that is 5 times 2, it's the 3, 4, 5 triangle, so this has got to be 3 times 2. It's the 3, 4, 5 triangle, 3, 4, 5 triangle, so this side's got to be 6, which is why I'm going to write my height as 6. Simplify that, 2 times 1, 2 times 4, 4 times 6, 24, 24 take away a 4 is a 20, so that's my answer of the shaded region. Done. Next question. Question number 15. Two sides of a triangle at 8 and 6. Okay, 8 and 6, that looks too familiar. We just saw an 8 and 6 over here, right? 8 and 6, the triangle. The two sides of the triangle are 8 and 6, which is not a possible third side. Okay, one more thing that I should highlight about triangles is that any two sides, let's say we've got the sides A, B, and C. Any two sides add up to be greater than the third side. Any two sides add up to be greater than the third side. Any two sides, what's left? B and something? A and B, I think. Has to be greater than the third side, C. So that's something, that's a rule of triangles that we need to know, which is what they're using over here. So basically, if I have one of the sides is 6, that means I'm looking at a 6, 6, 8 triangle. That's an isosceles triangle. It is possible, right? Try and mix and match the sides, and you'll see that this rule is true for it, because, like, let's say, for example, 6 and 6 will be greater than 8. 6 and 8 will be greater than 6. You try the rule for it, it would be true. Try the rule for the second one. So they're saying 8, 6, and 8 is a possibility. Yes, it is. You can have an isosceles triangle with 6, 6, 8. You can have an isosceles triangle with 8, 8, 6. You can have a right triangle with 6, 8, and 10. Just like in the previous question, we had 6, 8, and 10. How about 14? Remember the two sides, that means they're saying one of the sides is 14, the other one is 8, the next one is 6. Out of the two sides, 6 and 8, they should be greater than the third side. Is that true? Not in this case. It's not true. Which is why 14 cannot be a possible. They're saying not a possible third length. 14 is not a possible third length. Last question, question number 16. Which triangle below has a possible angle ratio of 2 to 3? Now they're coming back to angles. It's a question on the angles. We know that the angles of a triangle add up to give me 180, right? I've got 2, 2, and 6. So I know that when they specify ratios, I know that this is the simplest form. Most probably, everything would multiply with something to end up giving me a 180. So, for example, 2x, the first angle, plus 2x, the second angle, plus 6x, the third angle. All the three angles add up to give me 180. So the minute I can form an equation like this, the rest of it is just solving to work out what the three angles are. So 2x and 2x, I hope we're clear on how I got the equation. Basically, because I know ratio is the simplest form. So maybe it was like 4, 4, and maybe this ratio was 4, 4, and 12. Everything multiplied by 2. Maybe it was a 20, 20, 60. Everything multiplied by 10. So there's something that the ratio is multiplying by to give us the actual angles, which is why I wrote them as a multiple of x. Let's work it out now. So I've got to add them all up. Give you a 10x, which is 180. X is then 18. Now that I know x, I can multiply back into the ratio, which was 2x, 2x, and 6x. 2 times 18 is a 36. 2 times 18 is a 36. 6 times 18 is 108. What triangle is that? With these three sides, it's not an acute, because acute is all angles less than 90. Not a right, because in right one of the angles has to be 90. And an obtuse angle, because one of the angles is greater than 90. The other two are less than 90. Equilateral, no doubt all the three lengths are equal, so which is why we go with option C. This is an obtuse triangle. That's it. We're done for today. Make sure we we keep up with the comprehension practices, and we'll catch up tomorrow with the quadrilaterals and again comprehension practice. Until then, keep shining.